Bismillahirrahmanirrahim. Here I come up with the question number 6 of exercise number 2 of triangles, and that's the question which is related with the basic proportional theorem, or we can say Taylor theorem, and this is the question which is generally asked in the examination. In the question, it is written as ABC is a trapezium in which AB is parallel to DC and its diagonals intersect each other at point O. And what we had to show? We had to show that diagonals AO oblique BO is equal to CO oblique DO. That means the diagonals of trapezium are proportional. So before going through the question, let us have here the figure of trapezium that is like this. You have studied in your earlier classes that trapezium, it is a quadrilateral. It is a quadrilateral in which at least one pair of opposite sides are parallel to each other. Here is a side AB and it is parallel to DC. And let us draw the diagonals. AC is one diagonal and DB is the another diagonal. And these two diagonals intersect each other at point O. That is why I have written the given a trapezium in which diagonals AC and TB, or we can say BD, they intersect each other at point O. And what we had to prove? We had to prove the diagonals of the trapezium are proportional to each other. So keep one thing in mind. Once we talk of trapezium, it is a quadrilateral in which the opposite, at least one pair of opposite sides are parallel to each other, and these parallels are generally called the bases of the trapezium, while as the two non-parallel sides of a trapezium are called the legs of the trapezium. So we have to join in construction. In construction, we'll draw a line from point O that will intersect line segment AD at point E. From O, draw a line that intersects AD side at E in such a manner that OE is parallel to AB. That means in the construction, I have drawn OE line that intersect the line segment AD at point E in such a manner OE it is parallel to AB. So we get a triangle like this. Consider this as D, this as A, this as B. Here we are having O, and this is the line which is parallel to this OE line. It is parallel to AB. So this triangle. For in proof, we will take the triangle. In triangle ADB, this very triangle, ADB. What is happening on there? This OE, it is parallel to AB. Why it is parallel to AB? By construction. By construction, this OE is parallel to AB. Once in a triangle, we have drawn a line segment. If that is parallel to the either of the side of the triangle, that means OE, if it is parallel to AB, in a triangle ABC, as per the basic proportional theorem, the remaining two sides will be divided in the same ratios. So we can say DE oblique EA is equal to DO oblique OB. But keep this thing in mind, the common vertices of both the line segment. So from D we had to divide it. So by BPT, write down the rule, that is BPT, basic proportional theorem. With the help of basic proportional theorem, once the two sides are proportional in a triangle, the sides are divided in the same ratios. So mark this as first. Mark this as first. This is a trapezium. If this OE side is parallel to AB, this OE side is also parallel to DC, because AB and DC, they are parallel to each other. They are the sides of the trapezium, opposite sides of the trapezium. So we can say in triangle ADC, now this very triangle, or we can make it like this. Here is A, this very A, here is D, this very D, and here is C, this very C, and then we are having O here, then we are having E here. So in triangle ADC, this OE, it is parallel to DC by construction. So once such situation happens in a triangle, the sides are divided in the same ratio, but here the common vertex is A of both the line segment AD and AC. So we will write AE oblique ED is equal to AO oblique OC by BPT, by Thales theorem or by basic proportional theorem. But keep one thing in mind, what we had to prove and what we had to get in first very step, that is DE oblique EA. So here we are having EA or AE, it is the line segment, so we will write it as EA or AE. Here DE or ED, it is one of the same thing, it is line segment, here it is ED. But ED is at top here, where EA is at bottom. So here EA is at top, ED is at bottom. So we will take the reciprocal of this. By taking reciprocal, once we will take the reciprocal, we will get ET, or we will write it as DE as it is here, and EA, DE, EA, and same is the case here, OC and AO. Mark it as second. So compare this first and second. Compare first and second. We get, once we compare, here the left hand sides of both the equations are same. It means their right hand side are also equal. So we will write DO oblique OB is equal to OC oblique AO. AO. So we will transfer AO at the top, OB, or we need BO. Instead of OB, I will write BO. It is the line segment. Line segment is like this, O and B. Either we will write BO or we will write OB. So it is equal to OC as it is, and this DO will shift at the bottom. DO will shift at the bottom. So hence proved. Okay, hope that you understand it very well. Thank you.